Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the Biot-Savart law. So you can see that Biot-Savart law, what we are going to discuss now is the fact that we know that a moving charge creates electric field as well as magnetic field around it. And any current carrying wire has the moving electrons flowing inside the wire, and therefore we can say that a current carrying wire is the source of magnetic field around it. So from this section we are going to start the calculations of magnetic field by the current carrying wires. So the basic rule to calculate the magnetic field due to a smallest current carrying wire is given by Biot-Savart law. So in this law you can see that this is a current carrying wire of any arbitrary shape, and there is a small length of the wire dl here. This due to this small length dl, the magnetic field at a distance r at a point p, this angle is theta, will be given by Biot-Savart law. And according to this law, the small magnetic field due to this small elemental wire at the point P will be dB, and the magnitude of that field will be proportional to the current flowing in the wire as well as the small length of the wire, and sine theta, where you can see that theta is the angle between dl and r, and divided by and inversely proportional to r square. And when we will eliminate this proportionality sign, that then a constant will appear, which is mu naught by 4 pi and I dl sine theta upon r square. The value of mu naught by 4 pi is known to us as 10 raised to power minus 7. So mu naught upon 4 pi will be equal to 10 to the power minus 7. So dB is this. So dB will be equal to I dl sine theta, mu naught I dl sine theta divided by 4 pi r square. Now let us discuss the direction of this magnetic field dB, and also the fact that this magnetic field is in the perpendicular direction of plane containing dl and r. For that, we have to understand the vector form of Biot-Savart law. So let us now discuss the vector form. Vector form of Biot-Savart law. Now we know that any vector dB will be represented by its magnitude and the unit vector dB cap. And the magnitude of dB is mu naught by 4 pi r square into I dl sine theta into dB cap. This is the vector value of the magnetic field. Now what we are doing, we are multiplying r cap mod with this equation. You know that r cap is the unit vector and its magnitude, which is r cap mod, will be 1. So we can multiply r cap mod with this equation because we are just multiplying 1. So dB vector will be mu naught by 4 pi r square I. Now you can also write down dl cross r cap, dl vector cross r cap. So if you will open this cross product, then you will get as dl modulus r cap modulus sine theta and dB cap, where sine theta is the angle between dl and r, you can see. So this can be written like that, and r cap can be written as r vector upon r modulus. So dB vector will be mu naught I by 4 pi r cube, and this will be dl cross r. So this is the vector form of Biot-Savart law, and we can also predict the direction of magnetic field by this law. You can see that this dl in our case was like that and r is like that. So the plane containing dl and r is this plane, which is the plane of this screen. And at point P, the magnetic field will be denoted by the cross product of dl and r, and therefore we can say that cross product of dl and r is a direction which is perpendicular to the plane containing dl and r. So the magnetic field will be perpendicular to this plane of the screen, either in the downward direction or in the upward direction coming towards the observer. But in this case, magnetic field is in downward direction, because you can say that you can rotate your fingers of the right hand in the cyclic order starting from dl to r. So if you will rotate your fingers of the right hand from dl to r like that, dl to r, then your thumb of right hand will be pointing in the downward direction. So magnetic field at this point dB will be pointing in the downward direction. So guys, this was the complete analysis of Biot-Savart law and its vector form, and in the next video we will be bringing the applications of Biot-Savart law. Thank you.